Let's look at using the change of base formula. Now we're using the change of base formula when the logarithm does not have a base we can put in the calculator. So we're talking about those common logs of base 10 and then our natural log of base e. If it has any other number for the base, you need to use this change of base formula. Our basic change of base formula is going to have the base of b with our argument of n, and we're converting this by changing it into a fraction with log on top and bottom, and these two logs are our common logs. Our argument is going to be in the top or numerator, and our base is going to be in the bottom or not our denominator, so base on bottom. You could also use natural log. I usually don't, but it doesn't matter which one you use as long as you're consistent on what you put in the numerator and denominator. So let's look at our first example. Log base 70 of 19. Obviously, this 70 is not going to be a base 10 or e, so that's why we're using change of base formula here. Now, I like to just kind of think of this as writing it straight across. So log of 19 divided by down log of 70. Okay? And again, the log is on top and bottom. I don't want you to write it like this. I see sometimes students write it like that. It has a log on top and bottom. Okay, so both of those, not like this. And then you're going straight to your calculator to put this in. Again, these directions are saying round to 4 decimals, but make sure you read the directions in your homework to make sure you are rounding to the correct number of decimals. So in our calculator, we're using that log button, 19 divided by log of 70. And if you, depending on your calculator, you're likely going to be given this parentheses, but you need to close out before you do the divide and then close out of that last one and hit enter. This is going to give me 0.693. Hold on, let's try this again. Let me write it up here, 0.69305. Okay, and if I'm rounding to 4 decimals, 1, 2, 3, 4, looking at the fifth to determine the fourth. If that number is 5 or higher, we are rounding up 1, and it is, so this is going to be 0.6931. Okay, let's move to our next one. We've got log base 13 of 21. So again, we're going to do log of 21 divided by log of 13, base on bottom. And then we're putting that in the calculator. So log of 21 divided by log of 13. This is going to give me let me write it up here, 1.18697. And we are wanting to round to 4 decimals. So 1, 2, 3, 4. Look at the fifth. Now, how do we round a 9 up? Okay, 7's definitely rounding the 9 up, so that means this is going to change to a 0, and you're going to carry the 1 here. So this will be 1.1870, and you really don't need that last 0. That's how that works out, okay? Lastly, we've got log base 5 of -2. So this would be log of -2, so you can go straight across and then straight down, divided by log of 5. If I put this in the calculator, log of -2 divided by log of 5, I get domain error. Okay, we haven't really talked a lot about this, but the domain of logs is from basically not including 0, but 0 to infinity. Okay, so the domain of log, if you haven't seen the graph yet, but this is what it kind of looks like, and this gets really, really close to 0. So it's 0 to infinity, which means that I don't have any negative values for the domain. So if I'm trying to find a negative, it's not going to be in the domain. So in the computer, you're going to type does not exist or D&E. Okay, so log of negatives does not exist, and then you can see how to do the other change of base formulas if we do have all positive numbers.